Okay, so what we've done so far is we've set up a static level switch path from PE, or from our PE1 across to our PE2, and now what we're going to do is we're going to set up a path going the other way. So under Edit Protocols MPLS, which is where we need to be, so let's go ahead and set up that path. I think we have just dropped my connection there. Let me just get this up again. That one's working right. No. Okay, I think we just dropped a connection. Let me just get that back up again. Yep, indeed, we did drop the connection. Let's restart it. You probably find that you might drop a connection if you go away for a while. Okay, that's where we need to be. Let's go and set that up. Set a static level switch path. We're going to call this my static LSP. We want a dash there. The ingress. So this is, oops. This is our ingress router for this LSP. We're going to loop back the other PE 1.1. Okay, let's jump into that hierarchy right there. I'm just going to go like that. Okay. Edit. Where are we? I want to go there. That's it. Okay, so what we're going to do, we're going to set the next hop and set the label. And the next hop is, look at our diagram, is 172.22.212.2. That's our next hop, and our label, set push. Okay, our label is 1000, and in this case it is 102. Okay, let's check that. So we've got a we've got our next hop set up. We've got our egress set up, and we've got our label set up. So let's go and commit that and check if we worked. No, I wouldn't see that. We want to do a show MPLS static LSP ingress, and it is up. So there we are. So there's our static LSP, which is up. All right, so that is good. Now, what I wanted to do, let's just get this one back up and running again. Restart that one. Okay. So what we've now got is a static LSP going each way. So the first thing about LSPs is that they are unidirectional. So they only go one way. So if you want to return path, you've got to build an LSP coming back the other way. So let's take a look at our route now to that destination address. So we're going to go show route. So we're looking at the loopback address of the other CE. That's where we're looking for. 11.2. Okay, so what we are seeing is that in our PE, which is the inet.0 table, we have got a route to that destination, which is via a label switch path. You can tell it's via a label switch path because of the push statement in the route. Okay, we've also got a route in our CE, which is via our BGP peer between our CE and our PE. So its next hop is the 10.0.1.0 address via GE008. Okay, so that's our route to that destination. One of the things I want to take a look at here is let's just do a trace route. Let's do a trace route to 192.168.11.2. So I've got a bit of an issue there. Looks all right. Not really getting seeing that, what we want to see there. Okay, so so basically we've got the route, we've got our LSP, which is up. What we should be able to do, we should be able to ping the other address across our LSP. Let's make sure our LSP is up again. Okay, the state is up. That's looking good. Okay, so we should be able to actually ping from one CE right across to the other CE. And then we should be using our label switch path to actually traverse that particular link. So let's take a look on stats and do a show static, show MPLS static LSP. We want to look at our statistics and we want to look at the ingress. So far it's up. So far we've got no traffic has traversed our label switch path. What we want to do is get that path up and we want to send some traffic across it. That's really our goal. So let's try and ping between our paths. Or let's try and send some traffic through that LSP. So we're going to going to ping 192.168.11.2, which is the loopback address of the other CE at the other end, the one that's attached to PE2. Source is going to be the loopback address of CE1-1, so we are pinging CE1-2. We're going to ping it from CE1-1, so that's 192.168.1, and we want to put 10 through there. Actually, 10. And now we need to reference our routing instance, which is CE1. So really, we're using the route in CE1. So the goal of this is to ping from CE1 to CE2. I'm just looking like I don't really have a connection up here, and I need to kind of sort out why that is. Actually, it has sent 10 packets. Here's the interesting thing: it has sent 10 packets. Yet I got 100% packet loss. That would tell you that the problem was with the return path. So there's some issue with that return path. It's telling me that it's up. Still up. Okay. Two X top 172.22.212.2. Looks right. GE000212, that looks right. Outgoing label. Two. That looks right. Let's see, it's 1.1. Let's check this one here out. Show route to 192.168.11.1. Okay, there's my problem right there. I don't have a route. I don't have a route back to the other end. There is no route to there. Just check what I'm receiving from there. I am receiving that prefix. The next hop is 192.168.1.1, which is fine. Okay, now I've got a route. Probably just a bit of instability in the network there. Still not getting a return. For some reason. I can see the problem. My label value is wrong. Okay, that's my problem right there. I'm missing a 0. So if you don't get the label value right, your path will look like it's up, but actually it won't work. So let's go and fix that. Whoops, configuration mode. MPLS, let's do a show there. So my label value is missing a 0. There's my problem. Should be 3 zeros, not 2. Quick way to fix that. Replace pattern. 0, 0, 1, 0, 2, which is what I've got. And I should have 1, 0, 0, 0, or 1, 0, 2. So there's my problem right there. Let's take a look at that. That is looking better. I want to quit. And we'll have another go at that to see if that's going to work. I probably need to give it a chance to come up, I guess. Two, 1, 0, 2, which is correct. Still not coming up. State is up 172.22.212.2. That's my next hop. Correct. We're going label. Looks right. Let's check this one. I've got the same problem on this side. My label value is wrong. Should be 3 zeros and there's only 1, so let's go and fix that. Configuration mode. Yeah, got to get the label values right, otherwise your static MPLS won't work. Let's take a look at that. Yep, there it is there. Okay. Let's see if that's any better. Oh, hey, look at that. Amazing. Okay, so that's what we should be seeing with our ping. Okay, so yes, you must get the label values right, otherwise your static LSP will not work. So what we should be seeing is we should be able to ping from CE1-1, which is this first or from CE1-1, which is there, 11.1, to CE1-2, which is 11.2, and we're using routing instance CE1-1 because that's where the route exists. Okay, so let's take a look at what's happening here. Now we've got that up and running. We'll do a show MPLS static LSP ingress. There it is. It is up. We can take a look at the statistics on that. We'll see we've got some traffic going through that. So we have some traffic traversing that particular LSP. We've sent 10 packets. There's our 10 packets over there. If you want to just make sure that that's really telling us the truth, we'll send some more. Not working now. These things can be, don't be too troubled if a ping doesn't work. They can be a little unstable. Some of these parts that work perfectly. Let's take a look at the traffic on that. There we have now sent 30 packets on that one there. If you take a look at this one, we should see some packets on this one as well. And there's 30 packets on that one. They are the packets that we've actually returned on our ping. Okay, so there we are. So LSP is up and running. Okay, so let's just take a look at what we just did on the diagram. So what we just did, we actually pinged from CE1-1 right through our path across to CE1-2, and we used a label switch path, okay, in that particular for that ping. Let's just try a trace route, and we want to go to 192.168.11.2, and what we should see there, if we look at that trace route, what we can see is that we have in fact followed the label switch path there. So we've got the label value, so we're going to 172.22.210.2, which is our first hop. We've got a label value which we have applied of 1101. It then arrives at the next router, which has got another label value. Now that was already configured. You might be thinking, where did that come from? Well, that was already configured for you, so you didn't have to configure that. That static LSP has already been configured up across the P1, P2, P3. So we can see that it's gone across to 172.22.210.2, which is the address on P2, and then it goes across to the 172.22.206.2, which is on P3. So it's actually followed the path across the top. So if you go back to here, look at this diagram. It's actually followed this path across the top here. It's our static path. So that's that one there, P2, P3. So that's where our static path has gone. Okay. So we can see that when we actually are putting a trace route through, we are in fact following our label switch path on the way through there. Okay, so the question is then, how does the traffic get into our label switch path? Okay, so there's a question. Because let's do this. Let's do a trace route to 192.168.1.2. Okay, now that has not followed a label switch path. Okay, so here's the thing. We have got a static LSP from PE1 to PE2, so it's going from 192.168.1.1 to 192.168.1.2. All right, now I have just pinged 192.168.1.2, and I've pinged that from 192.168.1.1. Yet the traffic has not gone through a label switch path. Or I put a trace route through that, and the traffic has not gone through a label switch path. However, when I ping 192.168.11.2, the traffic does go through a label switch path. So my question is, why? Why does it take the LSP on its way to 192.168.11.2, but it does not take an LSP on its way to 192.168.1.2? Why is that? Any ideas? So the question is, how then does the traffic know that it's supposed to take a label switch path? How does it know that? Okay, so the answer is going to be here in the show route 192.168.11.2. Okay, so the answer is here, and the route to that is there. All right, that push label appears on the route. So the answer then is that it is BGP that directs the traffic into the label switch path. Okay, it is BGP. So if I was to do a show route to 1.2, which is the other PE, I have a route. Where is it? Let's just get this right. I wanted to do 1.2. That's what I want to see. That one there. Okay, so what do I have there? I have got an OSPF route right there. Okay, and I've got this other route, which is an MPLS route, sitting over here in inet.3. Okay, so when I do a trace route to 192.168.1.2, I've got there's two routes here. There's one sitting in inet.0 and there's one sitting in inet.3. Okay, so why do we not use this? Why do we use that? Why do we use that? Okay, anyone know the answer to that? Okay, well, the answer is this. The only protocol that can read inet.3 is BGP. Okay, is BGP. And there is no BGP route to 192.168.1.2. Okay, therefore, this never gets read. The only route that is actually used is the OSPF route. Okay, so it's our IGP's route that we're using. However, when I do a trace route again, let's do a trace route to 192.168.11.2, I'm using my label switch path. Why is that? Let's take a look at the route to 192.168.11.2. Let's just type it properly. That's what I want to see. Okay, I have got a BGP route to there. And that BGP route says we're going to go via that label switch path. So how does BGP know that it has to go via a label switch path? Well, BGP knows that, and it knows that because it, first of all, looks at its next hop. So BGP's issue is that it has a route. It has a route to 192.168.11.2. The next hop for that route is the loopback interface of PE2. Okay. Now that is an indirect next hop. So what it has to do, it has to resolve that next hop. And it does that by doing a recursive lookup. That means that it goes back into its routing table and says, how do I get to the next hop? So that is the question that BGP has to answer. So let me just take a look at this route again, and we'll just do the extensive on that. Okay, if we do an extensive on that, what we're going to find is, where are we going with this? Let's try that again. You have a problem with BGP, let's check it. Okay, we got a little problem with BGP, so we can't see that until this comes back up. You might get a bit of instability. I've noticed that there's a bit of instability sometimes within BGP. So we've got to wait for that to come back up to establish before we're going to be able to actually see that next hop. It will take a little time. BGP is not the fastest protocol in the world. Unlike OSPF, which is really fast, BGP is not that fast. But it's not supposed to be fast, so that's okay. Come on. We are really taking some time here. Finally. Okay, so this is the route that we are looking for here. We have got an indirect next hop. We have got it from our peer. Let's go down to here. What I want to look at is this indirect next hop information here. Okay, so the indirect next hop is go back up to, it's our source. Looking for my protocol. There it is. My protocol next hop 192.168.1.2. The question that BGP has to answer is, how do I get to 192.168.1.2? It answers that question by doing a recursive lookup into its own routing table. And this is the results of that recursive lookup down here. It's looking for how to get to 192.168.1.2. It does a recursive lookup. It finds that the next hop is 172.22.210.2, and it finds that information in here, inet.3. Okay, so that is really the key to BGP figuring out that it needs to send the traffic through a label switch path, because when we go and take a look at route table, inet.3, trying not to have too many N's in inet.3, what we find is this. So BGP looks in here, it says, okay, 192.168.1.2, how do I get there? I'll use this MPLS path there. Okay, so it gets that information, and from that information, what it realizes is, we're looking at inet.3, looking in the routing information base at inet.3, it realizes that the next hop is in fact a label switch path, and then it puts that into its route. So if we then go and do a show route to 192.168.11.2, that's where it picks up this label from, okay, which it got out of the MPLS, sorry, the INET.3 table. Okay, so basically the INET.3 is the table it uses to do a recursive lookup to find how to get to its indirect next hop, and the information it finds in there is that it is in fact a label switch path, which it then goes and installs into its routing information. Okay. Alright, so that is our static label switch path. Okay, so that's really, I wanted to have a bit of a look at that, see that that is up and running. Thing to be aware of is you've got to have your BGP protocols up, otherwise this will not work. So just take a look at show BGP summary and make sure that everything's established. If it isn't, give it a little time, it will come back up. Okay, I have noticed a little bit of instability in the topology. So if something doesn't work, don't panic. It's probably just this little bit of instability going on, and come back and check your BGP protocols and everything will come back up as usual. Alrighty, so we're going to go to lunch. When we come back, what I want to do is I want to take a look at using the RSVP route, RSVP label distribution protocol. Okay, and we're going to set up another label switch path, which will not be a static path. It will be an RSVP signal path, and it's a lot less work than setting up a static path. Okay, so the reason we set up a static path, this is just so that you can kind of see what's going on. Okay, doing everything manually, just to get the feel for, okay, this is what's going on, this is what's happening within an LSP. Just to kind of figure out how traffic gets into an LSP, see the traffic going through the LSP and so on. We are going to go back and set up an RSVP signal path after lunch. And then what we wanted to do is we want to go and talk about constrained shortest path first algorithm and how that works. Because that's where it really gets interesting. Okay. Alrighty, let's take a break and we'll come back at 1 o'clock.